Josh, what are you up to right now?
I'm making the LCD.
LCD, how's that going?
Just started.
What a wonderful diagram.
I know. Why are you videotaping?
It's for the video, bro.
What video? Hello all, this is Team 19 and our project Piano Jams, which consists of 3 parts. The 3 parts consist of a polyphonic electric keyboard that displays all notes being played on an LCD screen, an adjustable metronome that displays the BPM played, and a fully programmable drum machine sequencer. Diving into more of the keyboard's details, the keyboard function is wired to have an octave of 12 buttons connected to each of the digital input analyzers of the Arduino. These buttons were also hooked up to a laser diode that will light up when the button is activated, just to add a little bit of extra flair as well. A USB wire was wired up between the Arduino and a computer to allow for users to send and receive data from the online VCV rack piano library we built and utilized. The Arduino's code that we wrote's primary function is to continually check for the button's input and synchronize with the VCV rack piano library to produce a successful sound.
The metronome is fairly straightforward. The circuit has an LCD display that displays the BPM and a control button that the user can use to input the BPM. There are 2 available inputs, short presses and long presses. Short presses, with a duration of less than a second, increment the digit the cursor is currently hovering over and cause a short beep. Long presses, with a duration of at least 1 second, move to the next digit and cause a longer beep. With this setup, we're able to input BPM values from 0 to 999 inclusive. Once we long press over the final digit, the speaker will play beeps at that BPM. We also have a potentiometer that controls the contrast of the LCD display.
The drum machine consists of a line of 8 buttons, 8 LEDs, an additional button for changing sounds, and a potentiometer for adjusting BPM. The 8 buttons represent the 8 beats that play in one loop of the drum machine, with the drum machine looping infinitely. These buttons are latching buttons, and the user is able to press a button to toggle between turning on and turning off the sound for that specific beat. The 8 LEDs are used to represent the state of each beat in the sequence. If the LED is on, that means the sound will play for that beat, and if the LED is off, that means the sound will not play for that beat in the sequence. The state of each LED is changed by pressing that corresponding button. The additional button to the right is used to switch between different sounds. If our drum machine is a kick, snare, hi-hat, open hat, and clap sound, for example, this button here can be used to toggle between them so that the user can edit and alter the specific beat patterns of each sound. The Arduino code we wrote reads in the value of the potentiometer and changes the BPM of the drum machine based on what the user sets the potentiometer value to.
Positive. Alright, so we got the metronome here. Click. Oh, look at that. Hear that? Every time I click, it increments the digit. Gonna keep going. We want 60 BPM. So we're gonna hold it at 0. We're gonna hold for a second or more. You hear that? There we go. We're gonna increment again. Gonna go to 60. There we go. And then we're gonna go to 0 here. We're gonna hold. We're gonna hear a 60 BPM beat. Perfect.
Okay, so here we have the drum machine. Right now I have this LED on, so it's just hitting this first beat as it loops through. If I hold down this button, this LED now turns on, so now the kick will be playing twice for every 8 steps. I can click this button here to change the sound, and now I can input in the snare pattern that I want. I'll switch to another sound, the hi-hat, and put in a pattern that I want. That's how the drum machine works.